Hello, everybody. A very cordial welcome this afternoon to all of you. Maybe also a good morning or a good evening. Hopefully not a good night, because I wish you have also a night with us working. So very welcome again to our first DiBiCoo virtual study tour, which was created because of the COVID situation, and we couldn't have a physical meeting, so we tried to make it this way. Further explained later. DiBiCoo is a new funded project within Horizon 2020 of the European Union, and the aim is the cooperation of projects from Europe, projects within biogas and gasification sector, and bring this project or this project idea and this technique to upcoming biogas and gasification markets all over the world, and especially here to our partners in Africa, South Asia, and Indonesia at first, but also it will be hopefully implemented to all over the world. My name is Franz Kirchmeier. I'm staff in the Austrian compost and biogas sector, and there responsible for the biogas and gasification sector. Here, especially, we work with our government on regulations, on further developments, and also we are included in some research projects. I will further on moderate this session, and I'm very happy to have our speakers with us. In the background, who is responsible for the whole tool is Senja from Ethiopia, and very proud to have here with us Bernadette Martner from the biogas plant Bruck an der Leitha, Reinhard Walk from the biogas plant constructor and planning company from Töni Energy and Rowe Energy, who planned and constructed the biogas plant in Augsburg, and at last Josef Höckner from the biogas plant in Austria, Utzneich, and also the CEO from BioG company. And my colleague Florian Bronner, which is with me in our association in the biogas department. What we did, due, as I mentioned, to the COVID situation, we thought, and we have the contract that we show the European biogas technique and gasification also to other countries, to other stakeholders, interested stakeholders. And due to this COVID situation, it was not possible to have those excursions in physical. So we thought a little bit about it, and we thought, okay, what it would be maybe nice having a virtual study tour, meaning we film the process in the different biogas plants and then upload them, these videos, and ask the participants upfront the webinar to look the videos, to stream the videos, and raise the questions now during this webinar. The most important thing is here you have the opportunity to raise your questions to these plant operators or constructing companies, etc. Which plants did we choose? It was very important for us to choose plants which are hopefully interesting also for further markets, and therefore we choose plants mainly dealing with organic waste streams from households, from caterer or other organic waste streams, and one plant deals with agricultural residues like manure and straw. Additionally, these plants, one has a GHG plant integrated and use of heat of the external, the additional heat, which is not used for the biogas plant, and the other two plants have a biogas upgrading system installed and inject their biomethane then into the gas grid. So we hope we have chosen three very interesting but sure different plants. One of them is run in a dry plug flow digestion system, and two of them are run in wet digestion, as you may already saw in the videos, hopefully. So This new format I mentioned already was first look at the videos and now having the opportunity to raise your special question to the operators or the construction person, which is here again. We would like to start with the plant in Augsburg, and I would like to ask Sinja to start the intro. We are not looking the whole video, we are only showing the intro so you realize which plants we are talking now. Sinja, please.
Augsburg, Germany. DiBiCoo is an EU-funded project within Horizon 2020. The aim is to bring established biogas markets together with upcoming biogas markets over the world. The waste treatment facility in Augsburg consists of an incineration plant next to a combined anaerobic digestion and composting process. The biogas plant deals with about 105,000 tons of organic wastes, such as bio-waste from bins and green waste. The output is about 45 gigawatt-hours of biomethane, which is injected into the gas grid and corresponds to a supply of around 4,500 households with renewable heat energy. Additionally, around 20,000 tons of compost and 23,000 tons of liquid fertilizer are produced per year. The proximity of the waste-to-energy plant is a great advantage, as the entire energy requirement for the system comes from the waste incineration. An integrated exhaust air purification system ensures that the odor-intensive air from the digestion plant does not get outside, but into the furnace of the thermal power station, where it is used as combustion air. In addition, the Biofilter also provides valuable services. It consists of crushed root wood on which microorganisms settle. These break down the odorous substances biologically. We are here in the waste entry hall, where the delivered organic wastes are received and stored in a flat bunker. The wastes are mixed with tree and shrub cuttings and fed to the coarse processing.
Thank you, Sinja. Thanks, Sinja, for showing the introduction, the intro of the video. As I mentioned already, we are not showing the whole video because it was requested to stream the video upfront and now raise the questions. This can be done in two different ways. As we want to have it mostly livable, we would like you to raise your question via raising your hand and the button. There should be a button on the right side on your screen within the tool. And then when I ask you to speak, you could raise your question verbally. This is the most preferred version. If it's not possible for you, if you want to use your question in a written form, please use the chat function and we will also deal with it. So maybe you raise your questions. It would be fine if you see it, so we could start. So, as I don't see the flags upcoming now at the moment, I would raise the first questions, which is very interesting for this plant because this is a plug flow dry fermentation plant. And Reinhard is one of the constructors and planning persons of this plant. There are two very interesting things. You use material, organic waste streams, which needs to be usually hygienized. And in this plant, the hygienization is done via the plug flow process. Could you explain us the validation process so you don't have to install an additional hygienization step? Reinhard, please, floor is yours. You have to unmute, Reinhard.
As Mr. Kirchmeier already mentioned, it's a plug flow digester. it's working in a thermophilic mode. That means we are heating the substrate up to 55 degrees and with a retention time of the material in the digester of 21 days. Within this time, in this temperature, the material is hygienized. And this is the main point we can say. And for the source separated organics, which is separately collected, we don't need a separated or a separately hygienization process.
Yes, but you also have to validate for the regulation that the hygienization works properly. So you need to include pathogens and show that it works. Could you explain a little bit how you do this?
Yes, we use a tracer, what we put into the digester, and on with the tracer we can see if the bacteria are coming out in the end or not. So it's in principle it's a tracing process.
Yes, and I believe, to explain it a little bit, this is done via bags, which can be diluted by the wet stream of the fermentation process, and within these bags are the pathogens, and at the end it will be controlled and checked if there is nothing anymore there, if they are dead. That's very interesting of this process. And the second point is what is very interesting. You deal with organic waste from household, I believe. Do you have any problems with impurities like plastic bags, etc., etc.?
Yes, for sure. You never get a 100% clean material. We have impurities of about 2 up to 4%. There are plastic bags in the waste. There are other materials as metals in the bio waste. But we have a material pre-treatment process, and we have metal separation in the beginning of the process. We have a sieving process, and in the beginning of the process we take out most of the plastics, and we follow the philosophy that we keeping in the beginning of the process the bio waste quite big, with a particle size of 80 millimeters. And so in the end of the process, after the composting and during the post-treatment, then we have the possibilities to take out all the plastics when it's quite dry, the material. So in the beginning of the process, when it's wet, it's always quite difficult to take these plastics out because it's sticking to each other. But in the end of the process, in the post-treatment, in the composting, it's much easier for us to sieve these materials out. Yeah.
Yes, and this is done mostly with dry sieving and what is called in English Windsichter.
The wind sieving method is quite difficult to apply, because in the beginning of the process, when the material is wet and sticks to each other, then it's quite difficult to blow it out. So we take first of all in the process a shredder, then a star sieve, and in the end of the process, when the material is dry, then you can use a blowing system, a wind sieving aggregate, to get rest out.
Thanks, Reinhard. And now the ice is broken. We have the first questions. May Sinja, you allow Matthias Kirchhoff to ask his questions verbally. Matthias, is it possible for you to raise your questions verbally, or should we repeat it what you wrote?
Hello, can you hear me?
Yes, very fine. Please ask
Perfect.
your question.
Yes. To be honest, I was in contact with Mr. Vesely from the plant itself, and as being a supplier for mobile activated carbon filters, we are interested in the gas cleaning of the biogas system. And he mentioned that they exchange the carbon quite frequently every 2 weeks. And yeah, that sounded quite often for me. How do you deal with these topics with regards to maintaining the plant and all the units of the system?
Okay. Here I can tell you a little bit about the gas cleaning process and about the problems you have if you deal with gas out of bio-waste. I think the point what you mentioned to exchange the activated carbon every second week, it was in the past. The company who built the biogas purification plant has adapted some steps in the biogas cleaning process, and I think the frequency of exchanging the activated carbon is not anymore in this short period. But what you have to deal with for sure, these are volatile organic components and very volatile organic components, which are loading the activated carbon quite heavily and quite fast. And these are problems you have to deal with in each different way of cleaning the biogas. We as Rovi Energy, we operate or we have service on different gas cleaning processes, and in each of these plants where you clean biogas from bio waste, you have similar situations.
Thank you, Reinhard. The next question comes from Hari Yuvono. Please apologize if I'm not using your family name and your first name right. May you say it right. Sinja, could you unmute Hari so he can raise his questions verbally, please? And Hari, could you please raise your question?
Yes. I've listened to the video, and I find that there are some discussion about pathogen in the material input material. I wonder if there are pathogen in the input material, how the biogas system can reduce the pathogen, and what are the standard use, what is the initial pathogen, and then what is the final that is acceptable. That's the question. My second question on the compost. From the video, I learned that compost are one of the products that is is the output of the biogas plant. I wonder what are the quality. Yes. What are the composition of NPK in the compost? And I wonder if in the 3 plants in the video, whether the composts are different from each other, or how is it? And because here I'm from Indonesia, compost is not largely used, and why in Europe compost are quite largely used, and it's become a good support for the economy of the plant. Thank you very much.
Yeah. To start first of all with the second question about the compost, we have already a very high compost quality, but we as we always say, shit in, shit out. That means if the quality of the bio waste is very bad in the beginning of the process, you have a bad quality not the best quality in the end. And the effort you have to do to sift all the impurities out is quite high. That means what we always have to mention is when you have a source separated collection, or if you treat bio-waste, the input material should be very clean. In this case, you get a very high quality of compost, because as we already mentioned, we have a process with 55 degrees of temperature and a retention time of 21 days. It's a thermophilic process, and we have already a rotting degree of 3 to 4 in the end of the digester. So after the digesting process, we have another 10 days for intensive rotting process, and then another 7 days until the material is getting really to a final mature stage of the compost. And after this time, you can bring it out to the agriculture, you can sell it then to gardeners and so on, and you really get a high compost product. But as I mentioned, you have to look for a good input material, and then you will get an excellent output material. And in Germany, we in most of the plug flow plants, we have this bio certificate for our compost, and this is the highest standard what you can reach, and so you can also sell this product on a good price level.
So could you say something about the NPK level, the nitrogen level, the main nitrogen, nitrogen, phosphorus, and potassium nutrients level? Sorry, I said it wrong.
This question I have to lay back, and maybe I tell you later a little bit more about it, or you can put this question direct to me on my direct contact.
Yes, Sandra will put in the email address which can be sent questions further on, and Reinhard will reply to it. Usually, what is maybe your question, Harry, was the main nutrients goes into the dry phase, meaning compost, and some parts also goes into the liquid phase, and this is also dealt and stored and brought out to agricultural fields in this plant. And there was one point again about the hygienization, Reinhard. Yes, the pathogens Harry raised. May you again explain that it is a validated process?
Yes, it's a validated process, and during this thermophilic process, all these pathogens are in principle killed, and this is guaranteed with the 55 degrees in the 21 days retention time in the digester.
Okay, thank you.
And furthermore, you can also say in the post treatment process, in the intensive rotting process, we have furthermore a heating up of up to 70 degrees in the compost, and there, if there would be any pathogens in the compost, it would be finally killed in the final step or in the post treatment. Yeah.
It's a typical secure step, because within the thermophilic process with 55 degrees, pathogens are destroyed in this plug flow digesters. So the next question, hope we replied to all your questions. The next questions came up from Johannes Anhorn. Johannes, may you, Sinja, may you open the microphone for Johannes, and Johannes, you may raise your question verbally.
Okay, yeah. Franz, can you hear me?
Yes.
Okay, perfect. Thank you very much for the opportunity to raise my question. I would be interested in the odor reduction measures that you just at the beginning showed from the plant using wooden chips. Could you explain a little bit to what level you're actually able to reduce the odor exposure from the plant? And then there's a second question. You mentioned that you also reuse excess air, and sorry, I didn't capture or memorize to what process you're actually using excess air and feed it in, but it was under the framework or the logic of energy efficiency. So can you actually quantify the effect of this reuse of excess air? That would be also interesting. Thank you very much.
On the one hand, we have in Germany the so-called Geruchseinheiten, the odor units, what we have to fulfill. This is always between 300 and 500, really dependent on the site where you are. In Augsburg, where you're really in the almost in the middle of a big city, you have to fulfill really low levels of the odor units. And we fulfill this odor levels on the one hand in the plant in Augsburg with the biofilter, where we have some wood chips in this filter, what you saw in the video, and on the surface of these wood chips there are bacteria, and the bacteria are fed with the air of the, or with the air of the treatment process, and the bacteria are taking up all this odor level and bring this down to the required units. On the other side, in Augsburg, we have an air treatment system in the incineration plant, and so we can use this synergy of the incineration plant, and we can blow the exhaust air to the incineration plant, and this is processed then in this part of the plant. So this is a quite good process if you can integrate a biogas plant into the side of an incineration plant. So you can use on the one hand the heat to heat up the digester. You can use the exhaust gas treatment for your exhausts in the biogas plant, and so you can use all these synergies on one site.
Thank you, Reinhard. Thanks, Reinhard. Thanks to Reinhard. I hope the question is answered. And we come to the next and the last question so far, and it came up from Joche. Sindre, may you give Joche the possibility to raise the questions verbally? Joche, can you raise the question?
Yes, I was asking regarding the gestate and all the post-treatment, if they were looking to upgrade it in order to increase the revenue and the income of the plant coming from that byproduct.
Can you say it again? Can you say it again?
Reinhard, may I explain a little bit? In German, it's maybe easier for us both. Ob man das Gärprodukt noch weiter aufbereitet, damit man mehr Geld daraus erwirtschaftet. Und da müssten wir jetzt eigentlich erklären, dass man einen Kompost hat und der hat schon höchste Qualität. Und das zweite ist flüssige Gärprodukt. Und vielleicht möchte Joche dort etwas wissen, ob ihr geplant habt, dass das noch weiter aufbereitet.
Ja, genau. In Augsburg, we are in the good situation that we can bring the liquid fertilizer into the agricultural. We have enough farmers around this plant to get rid of all this liquid fertilizer, and the liquid fertilizer is it's easy to be brought out. And on the other side, the solid fertilizer, the compost, could also be used in the agriculture, but if you furthermore put some, how can I say, nutrients into the existing compost, we say in Germany that what it means, with nutritions, then you get a higher compost quality, and then you can bring it to the gardeners and to households, and then you get a much higher price.
But it is already a high valuable compost. It has the highest label within the legislation process, and you could even upgrade this with further nutrients. Joche,
Yes.
is it answered right? Is it okay?
Yes, thank you. Thank you.
Thank you. There's one more question by Madoda Agrippa. Sindre, may you open the microphone for Madoda?
Hi, ladies and gentlemen. I just would like to find out if what would one need to start such a project for household purpose before maybe taking it to for business purpose. I don't know if I'm making sense. What sort of equipment? What is it that one would need? Because we live in a farm, and from time to time we get waste of from animal and stuff. So I just wanted to check if can that be maybe used for trial purpose before maybe expanding the project. I don't know if I'm making sense.
I'm not sure if you understood right, because the quality was really bad. Reinhard, could you follow?
Yeah, I think I could follow, or I try to follow. And Sindre, maybe you can switch over to my screen so that everybody can see my screen.
Sindre, may you switch the screen?
Can you see my screen right now?
Yes, we can see it.
Oh, now I have to go to the end of the presentation. Sorry for that. But we have a very special product in within Tony, and I switch over to this product, and it's called the Ox, the TTV Ox. It's a quite nice and interesting product. It's a very small digester. As you see, it's built in a container, and in principle it's the same just as a mini digester, I would say it like that. And if you talk about really small amounts of waste, this might be suitable particularly for African African utilization of small amounts of waste. And as you see, the principle is the same. You have a plug flow digester, you have a quite small agitator and a steering system. You pump in the input material, you take out the output material. In principle, it works in the same way as the big digesters with a quite big volume. And here you have this small digester. I can just give you an impression about the cross section of such a fermenter, and you can just imagine this is built in a 40 feet container, so you can feed your waste, your really small amount of waste daily in a flap and put it into that into a intermediate bunker, and then this small amount is then pumped into the digester. And yeah,
maybe have to interrupt because it's getting a little bit late. Did this answer your question?
The volume starts just as example. Okay. The volume starts here with about 20 up to 40 cubic meter of digesting volume, compared to the Augsburg where we have 1650 per digester. So you see the difference. And the biogas production is mentioned here as well, with 45 cubic meter digester or a volume. You get out biogas amount of 85,000 cubic meter per year. So the heating values are mentioned below. And yeah, I would be happy if you would be interested in such a product. Maybe I can send you some information about this very, very small digester. And particularly if you have maybe 2, 3, 4 farms, then it might be quite interesting for you.
So hopefully this question is answered right, and we understood it right.
Sinja, can you?
Would like to get more info. If Reineke could forward it to me, we'll drop you an email address.
Yeah, perfect.
Yes.
Sinja, can you? Sinja, can you go back again? Can you take us back to the normal screen?
Yes, yeah. Thanks. There's one remaining question. It came up from Bernhard Ruzek from Austrian IR. May Bernhard, you raise your question, and Sinja, you unmute him, please.
Bernhard, you should be able to unmute yourself.
Thank you very much. Brief question. What is the methane yield per ton of input material, the average methane yield, and would you expect a difference in methane yield between the dry fermentation system and the standard CSTR?
On the one hand, the gas yield on the source separated bio waste has big differences. Also in Germany, if you look at Augsburg, you're in a range between 90 and 100 norm cubic meter per ton input material. You go to other plants, you are in a range of 140 up to 180 norm cubic meter per ton of input material. This is quite impressive. If you go to different areas, maybe you're in a town, or you have different legal basics, for example, that you are just allowed to collect a green cut, then the gas yield is quite low. If you can collect more fruits, more really valuable organics, then the gas yield is much higher. So it really depends where you collect the waste and how the waste is collected.
Okay, thank you. And would you see a difference to CSTR?
If you compare the plug flow digester with a batch system, I would say it like that, then there's a big difference. It's about 30% difference of gas output.
Thank you.
Thanks to Reinhard. This was, I believe, the last questions. I'm right, Sinja and Florian, to this plant, so we could, yes. So thank you, Reinhard, again, and thank also for the first questions you raised from the audience. It was very nice to hear you all. We come to the second plant. Sinja, you may show the intro of Hook on the Leiter.
Market over the world. A very cordial welcome to the DiBiCoo study tour today in Bruck an der Leiter, Austria. DiBiCoo is an EU-funded project within Horizon 2020. The aim is to bring established biogas markets together with upcoming biogas markets over the world. The biogas plant in Bruck an der Leitha deals with about 35,000 tons of organic wastes, such as kitchen wastes, as well as wastes from food and beverage industry. The output is about 35 gigawatt hours of biomethane, which is injected into the gas grid. The capacity of the upgrading unit is 500 cubic meters of biomethane per hour. The organic waste is delivered by truck. Before emptying the containers, the trucks need to be weighted and documented. This takes place next to the entrance at the waiting bridge and the office. Since all the materials delivered are waste, they must be documented and treated in a special way. The material is weighed and assigned to a key number in the waste directory according to its composition and origin. Vegetable materials, whether solid or liquid, are easy to handle and can be fed to fermentation without any special pre-treatment. Animal materials, for example from fat traps, are more difficult as these have to be sanitized in order to eliminate potentially pathogenic germs. Hygienization takes place by heating the material up to 70 degrees Celsius for more than an hour in accordance with the hygiene regulations. The greatest effort is associated with the material.
So, thank you, Sinja, for showing the intro. May we start? Are there already questions from the auditorium? So far not. So we need again some icebreakers, Bernadette. It would be interesting, Bernadette, from your plant, as it is the first wet digestion plant we show, and it's dealing also with organic waste streams. The one thing is, and you deal with food leftovers, etc., or unused food. How to depackage the food you get delivered? And the second question is, as you deal with organic waste streams, I believe you have many impurities, and how do you avoid to get too much to bring too much into the digestion process? And secondly, if they're going into the digestion process, how do you deal with it? Which build an up layer or an bottom layer of impurities like sediments?
Okay, so maybe I try to start with the depacking.
Yes,
we have a lot of impurities, and we have a lot of waste directly from production places. So a lot of packing. In the end, it's a quite simple process. We put all the waste together in a bunker. We have screws for transportation, and then we have a kind of crusher. But the crusher works in a way that packing material is not crushed as much as organic material due to the specific weight. So we also add some water, so we can make a we make it liquid, let's say. We crush the organic, and then we have further a shredder, and then another screw with sieve below. So the organic material is going through the sieve, whereas the inorganic fraction is transported over the sieve out into our waste, let's say. Yeah. So there is almost no packaging going through the fermentation process, and in case there is some, we sieve it out at the end before bringing the digested on the field.
Yes, what we saw on the video, you have a sieving process. It's a new development because due to the new fertilizer regulation on the European level and what also comes into force in Austria, you have to avoid to bring out to the fields, to agriculture, microplastics, etc. And therefore you have to sieve your outcomes before you apply it. This is a new development, and it's very interesting that we can solve the problems a little bit, but better would be not having impurities in the process at all. So what do you do with the sediments?
The sediments, we try to clean each year one of the 3 fermenters. And yeah, we have to empty them complete. And then we go in with the word of English, sockbagger.
I believe that we won't find quickly.
Okay, I'm missing a word. So we have to pump it out, let's say, with a heavy-duty machine.
Dredge.
How's it called?
It's a suction dredge.
Okay. Yeah, we use this.
Down here in the yes.
Yeah, we use the big machines to empty them.
Okay, thank you. We had a first question, a flag raised by Sisse Mekip, but he put down his hand again, so I'm not sure if it's still a question or not. Sinja, you may give Sisse Mekip the floor, and you could raise the question personally, verbal. If it is not, please let us know.
Yes, I think it came from Shinta.
Yeah, that's me.
Fine, we can hear you. Please raise your question.
Thank you. So before I heard Reinhard mention about the methane yield per ton of the feedstock can be up to 180 normal cubic meter, right, per ton of the feedstock.
Yes, but this is a fresh mass, and this is a really difficult yield.
Okay.
It's not very precise. Reinhard knows it. We don't, because it's you have maybe feedstock streams which are very wet and low organic load, and on the other hand, you could also have kind of biofertilizer, which is also can be a waste product, and then you have a very high yield from the fresh mass. So better is always to go to the energy yield in methane per volatile solids. That's the only figure. And for waste treatment plants, it's very complicated to say it in total, because the mix changes. Bernadette, you may explain a little bit further.
Yeah, the potential methane yield is varying from one material to the other. It depends on the composition, and even if you have one waste stream coming out of some production process, the quantity may vary from one day to the other depending on how the production process is working. So I mean, if you compare it to dry matter, sometimes you have a material with the same material stream, theoretically, with a dry mass content of, I don't know, maybe 22%. And the day after, you have it with a dry mass content of 8%. So it's varying from day to day and depending on how the production processes before are working. So to say an average yield is almost impossible. Because in the end, we have to deal with with the material we get. Sometimes it's very wet. Sometimes, yeah, there is much more dry matter inside. So to give an average is almost impossible.
Thanks.
Okay, so if the feedstock is what is it not vary, I mean only one individual feedstock, do you think the methane yield will be much higher?
For dry or wet fermentation, you mean? Is
Yeah,
this the
for
question?
dry fermentation technology.
Well, honestly, I cannot tell you. I just know the process we have here, and to compare it for the same material. Well, I cannot answer the question.
Yes, let's explain it that way. If you would feed in this CSDR reactor digester, which Bruck-and-Leiter uses, and you would feed the same feedstock they use in Augsburg,
this would not
it
work.
would be a little bit difficult.
Yeah, definitely.
If you
I would rather ask the question in the opposite way. What kind of material you have, and depending on the material you have, you decide for one technology or the other. Basically, we have very wet material, so we use also the wet digestion.
If we would use those feedstock, some kind of feedstock in the dry fermentation plug flow plant in Augsburg, you may achieve the same yield within this 20 days. But then you don't need to compost it anymore because there's nothing left for composting. Because the digestate in this wet digestion plant used in Bruck-and-Leiter, and depending much more on the feedstock, on the liquid feedstock mostly, you have a wet digestate, which is not very good for post-composting.
At the end of the digestion process, we have a dry matter content of 3%. So
it's mainly sediments, anorganics, and nutrients, what is left over. So it's really
different feedstock.
Why we choose these two special plants for typical organic waste streams was really to show, if you have a special feedstock streams, please use a special technique. Adapt the technique or choose the technique to the feedstock streams, and not to try to pre-treat as long as needed the feedstock stream, so it is applicable for the digestion process you want to have. It's maybe the way other around. See which feedstock stream you mainly have, and try to find the right digestion process. Like in Augsburg, they have mainly very solid feedstocks coming from households, from gardening, etc., and then use a plug flow digestion process. On the opposite, Bruck-and-Leiter has many liquid feedstocks, and therefore the liquid process is maybe the most profitable and the most suitable here. We have a question from Harry. Again, please, Sinja, could you give him the floor? Unmute him, and Harry, may you raise your questions?
Yes, I saw in the receiving hall, I think the material is, evaluated. It seems, I don't know, or they said in the computer, I don't know. But I believe there are variation of the material input of the biogas plant. For example, like it was mentioned, if there are impurities, you have to do sieving or something like that. If the impurities are too much, for example, what do? Do you reject it, or you will charge more to the people who bring the raw material into the biogas installation? That's the question. Yeah.
Okay. I mean, in the end, it depends. If you want to get a new contract, you usually try to check the material before you make the contract. Then you see the consistency of the material. If there would be a lot of glass packaging, we would not take the contract. We would not make the contract because we're not good in dealing with glass materials. If it's plastic materials or metal material, packaging impurities, it's not a problem because we can sort it out. Yeah, we have contracts with customers where the material consists of, let's say, almost 30% of packaging. You just have to evaluate then from price point of view, because we also then have to, we have a high amount of waste ourselves.
So therefore, may I add, you have different revenues for feedstock streams you ask for. That's important.
Yeah. So then the more waste or the more complicated the materials, the higher the price.
For those streams which you have, which are put out during the depackaging process, you have to give it to the incineration plant, and it's highly costable.
Exactly.
You have to pay for it.
Thank you.
Is the question answered? Yes. So I don't see any hand raised anymore and no questions written down. So Bernadette, yes, maybe one last remaining questions. Would you also deal with household wastes?
We thought about, okay, so far we don't do it. We thought about it, but the problem is if it would be just food waste inside, it would not be a problem. But since there is also a lot of, let's say, wooden material, it would not be digested in our system. So from this point of view, no. We have one customer where they try to collect in a separated way food waste and wooden waste from private households. And then it's working without any problem.
Yes. So it's again, if you know the feedstock, you choose the right technique. And there's a really difference between if you use then dry fermentation or wet digestion. This is a main issue during the time you plan the plant and set up the model you want to have from technical options and also from business options. So Bernadette, we have no questions anymore. Thank you for joining and answering the questions. If questions coming up later on, we will forward it to you. Thanks. And
thank you.
Sinja, please show the third intro for the third plant. It's Utzeneich, the biogas plant in Utzeneich, and this plant deals with agricultural residues, manure, and mainly, and this is the important point and the difference to the others, mainly straw or agricultural residues. Please, Sinja, show the video.
A very cordial welcome to the DiBiCoo study tour today in Utzeneich, Austria. DiBiCoo is an EU-funded project within Horizon 2020. The aim is to bring established biogas markets together with upcoming biogas markets over the world. The biogas plant in Utzeneich deals with about 2,000 tons of catch crops, 6,000 tons of maize straw, 500 tons of grain straw, 500 tons of grass, 1,500 tons of manure, and nearly 2,000 tons of slurry. The electric capacity of the CHP is 500 kilowatt, and the annual output is about 4.2 gigawatt hours of electricity and about 4.2 gigawatt hours of used heat. The catch crops and the maize straw is harvested at the same time, so the feedstocks can be unsealed at the 3,000 square meter silo. Whereas the straw has itself a too low water content for ensilaging, catch crops are an ideal partner, making sure that the ensilaging process happens properly. Every cargo is weighted and documented. This takes place next to the entrance at the weighbridge and the office. Next to the weighbridge, the delivery system is located, wherefrom the main digester is fed. The digesters are built as a ring-in-ring system. whereas the main digester with a capacity of 2,300 cubic meters is the outer ring. The 2,100 cubic meter post-fermenter is located internally. The digestate is stored at 5,800 cubic meter storage tank and is used as fertilizer at the right time and the right rate. The feeding system is filled with 30 tons of substrate every day. Via a walking floor, the substrate.
Thank you, Senja, for the intro. And may you, yes, now Josef Heckner is already here again. He is the CEO from the biogas plant and also the founder of the company Verity, which deals with development of pre-treatment systems for straw and other agricultural residues. And they have made great development, pre-treat these feedstock streams, which are a main source in future biogas plants. So please, if there are already questions, please raise them. So there's a question from Enoch Echipong. I'm not sure if I've thought it right. Senja, you may open the micro, and please, Enoch, apologize for not saying your name right, and may you explain yourself.
Is this Noch Meyer?
Noch Echipong.
Yes, yes. Just a second.
Yes, fine.
Hello.
Yes, we can hear you. Please.
Oh, great. So yes, it's Enoch Ejipong. That's fine. So I just wanted to confirm that with some of these anaerobic digestion processes, the capacity of these installation, can they be sort of miniaturized? Can they be made smaller? Because in some instances where here in Ghana, in the rural community, I see that there's the need to sort of be able to have energy and environmental solutions mixed up, but usually these are very small communities and their level of feedstock would not be as high. So I was just wondering what the economies of scale are if you are having smaller plants per se, and is there interest from technology manufacturers and developers like yourself to engage in some such activities here? Thank you.
Yeah, you can build smaller plants, but we are not a biogas planning company or not a biogas. We are not build any biogas plants. We produce technical components for biogas plants. So this is feeding, it's devibration of the material, and also biology things in the biogas plant. But we are not a biogas company.
Right. Okay.
Biogas company.
Yeah.
But you can do this smaller. Yeah? Absolutely. Yes.
Yes. You can go smaller. Absolutely. And there will be a matchmaking tool on our website on DiBiCoo, which will be launched soon, hopefully. And there you can find the companies which are planning companies and construction companies for small and big plants. These are really different companies who deals with it, and may you find then the right company. If it's for the pre-treatment, then Josef Höckner from BioG is a very good company.
But we have seen before the pictures from Tony from the very small digester. These are digester. They are absolutely they works with this material with straw and these things with field waste. They can work with these things.
Right. Okay. So that's noted. I wanted to confirm that because from the Renewable Energy Association of Ghana, there's the strong inkling to have different types of collaborations that would either go ahead with assembly or manufacturing here, or to technology to transfer technology and have such engagement. So yeah, just to put it out there and then to see how we can synergize moving forward. Thank you.
Thanks.
Thank you.
There's a question from Bernhard. Sindra, may you unmute him?
Hello?
Yes, we can hear you.
Yes, hello, Josef.
Hello.
You are dealing with straw, and my question is, you're actually invented the biochip, the machine to chop and harvest in one step, especially maize straw. My question is, if you are not able to do this step, for example, if you want to utilize rice straw, for example, and you have to deal with the big, like the original size of the straw, the native straw, which disintegration system would you recommend to chop down the native straw, and to which particle size? Do you have a do you have an idea about this?
Yeah, it's not important. It's important, but not so important, the particle size, but it is important, the devibration, the size of devibration. The big problem is you have not enough surface on the material for the bacteria, but you can devibration the straw, especially rice straw, but also wheat or barley straw. They have a very good lignin structure on the outside. It's easier with maize straw, with corn straw, it's easier. But if you have rice straw, then it's very important to do a devibration. It's more than trading. Devibration is more than trading. It's not only cutting the straw. You have to separate the fibres, each fibrous. Then you have enough surface for the bacteria, and then the bacteria can also work with this material. But the devibration, it's the big point for the whole system with straw.
And do you have an idea which technique could achieve this devibration properly?
Yes, we work with different devibration machines, and I can. When we can share maybe my screen, then I can show you also a picture about this if you want.
Yes, please.
Maybe. Is it possible?
Would it be possible?
Yes, sure. Just a second.
I don't know, is this the right screen or the wrong screen? I have two screens.
We don't see nothing. We see you
can see
your young face.
My young face, yes, that's me.
Oh, that's you, yeah.
You can see the devibration?
No. You don't. At the moment, you're not sharing the screen.
Just a moment. My screen, just a moment.
Now we see what you have installed. Yes, fine.
You see?
Fine. Yes, fine.
Okay.
It's okay.
These are two of more devibration machines. First, we have a look on the material, then how many tons you will use per hour, and then we look for the right devibration machines. But normally there are hammers inside that go with a high speed with 1,000 turns. Crash the straw, or crash with a high speed on the straw, and then you get the devibration. Normally it's enough, but if you have very long straw, then maybe or very stable straw like rice straw, then maybe it's necessary to do a second step, or to do a second vibration first a shredder with not a shredder, first a cutting machine, and then the defibrillation machine. But it is really only necessary by very long Reisstroh, not for the other things. For the other materials, wheat, barley, corn straw, it's enough if you work with one of these defibrillation machines. If you need a higher speed, then we have also other machines for the defibrillation. After defibrillation, normally we go dry or wet into the digester. If we go wet to the digester, then we work with liquid pumps. You can see here the defibrillation machine and then a liquid pump, and so you can mix the solid with the liquid. If you have then drier the materials, then more the direction to liquid feeding. But if you have normal manure like cow manure with, I don't know, 25% of dry matter, then it's also possible if you go directly into the digester with an auger. And this is also very dependent on the on the kind of digester. If you have a full mixing digester, then you can work with the drier materials. If you have a mixing system where you only mix parts of the digester, then it's better if you work with the liquid feeding system. But for this, we have to look on the whole system, on the whole digester system from the existing digester system.
Thanks.
Thank you very much.
May you close the screen, Sinja? I'm not sure, but I have one flag raised, one hand raised, and it's from Enoch. Enoch, is it you still? You have a question? Sinja, may you unmute him so Enoch could reply and raise the question? And if it's not, please let us know.
Enoch, I have unmuted you.
Yes?
Okay, maybe it's the old one.
Maybe this is the question from past. And Harry raised the question. May you can unmute Harry.
Yes, thank you. On the compost that is produced from agricultural waste, I wonder if you have an off-taker for that, and what are the reasons why people are buying all the compost that you produce, whether it's already competitive in comparison to fertilizer, ordinary fertilizer? That's a question. Thank you.
I'm not sure it was a question for the first biogas plant for the dry fermentation. A short answer from my side, Josef. May you go further on. The compost is very important because it has a high content of organic carbon in it, and additionally, it is hygienized. So it's a very valuable source, a very slow feeding nutrients system, organic system to the soil. If I have a decorated soil, it's very valuable. It increases the field capacity, meaning if you have a season where it's humid, high humidity, and then low humid, low rain, so it increases the field capacity, so you may not need to irrigate. The soil is upgraded. It's a very valuable source. The first questions you raised about compost, I couldn't follow. Sorry, or maybe I answered already. Is it answered?
I mean the off-taker, whether your compost that you produce in your factory is bought out by someone else. Off-taker, buyer.
The buyer, the consumers.
Yeah.
It's in agricultural use, and the landscaping companies mainly buy it. If they create a new garden, have to create a new garden or something like that, they really like to buy it because it's a very resource. And when you then start when the growing season starts, they have always a positive effect, and the consumers like it.
Okay. Thank you.
I have a question here about the empty fruit punches, the methane yield. It's about 160 norm cubic meter per ton of dry matter. We have used this also in, we have tested this material. I have seen this question here on this line.
Okay, fine. I can't see it, but it's good if you have better eyes than I.
Yes, I'm younger.
Yeah, fine. So, are there further questions? Maybe two questions from my side. The one is really interesting is, and maybe it's also for other countries, if we deal with straw, usually straw has a moisture content and a structure which doesn't allow it alone, because it's not dry enough, and on the other side it is too wet to store it as dry system. So how do you deal with it?
It's not too dry. It's too dry if you will come over 75% of dry matter. Yes, then it's really too dry. But it's too dry to be a silage, but it's not too dry for storage. Normal, the cheapest way is always a silage clamp. Also for dry straw, the cheapest way is a silage clamp. Bowls are more expensive, square bowls or round bowls, they are expensive, and so we favor the normal silage clamp. And if you have very dry material, you get no corn straw silage, but the corn straw will come out again like before. It's no silage, but it's a dry straw. But you have no problems with any Verpilzungen.
Ja.
Was sind nochmal Verpilzungen? Das gibt's. Egal. And the cheapest way will be the silage clamp, but if you are not sure and you think you will work with a silage, then you can also mix the dry straw with other products in this time, and this will be maybe materials from sugar beets, from the sugar beet harvesting, or materials or wet grass. It's also material from this time. Then dry wastes from other company organic wastes, they are all possible. Or maybe the whole crops after wheat, the mixing crops of, I don't know, sunflowers, clover, whatever, and all these things you can harvest in this time, where you also use the corn straw. And if you mix this with the wet material, then you will get really a good silage. Yes. We do this now, I think, over than 10 years. We work with corn straw, and never we have get a bad silage in this time.
What you meant with Verpilzung in German, if it's too dry, you would get fungi, and you have too much oxygen in it, and the density is not high enough for the silage, so the oxygen is not pressured out, and then you would have a degradation of the organic material. that's why you use also additional a second crop or a second waste streams, organic waste streams, so you have a better silaging process. So there's one question come up from Gustavo Solorzano. Sinja, may you give him unmute him, and so he can raise the question.
Yeah, thank you very much. I was wondering if you could let us know about the tipping fees at each of the 3 places, and also if there is a market for the liquid fertilizer, maybe it's for any of the 3 presenters, or the 3 of them, whatever. Thank you very much.
You mean the revenue for a feedstock?
Well, what anyone who is taking the organic waste to the facilities, yes, how much do they have to pay per ton of organic waste?
Yes, maybe we keep these questions. Have then after Josef's plant a last round with all speakers, and we could raise this question again. Would it be possible for you? And we have, I saw there was one final raised hand. I believe it was Sinta or the Sisse. I'm not sure again.
Yes,
Is there still a question?
Yes, I have unmuted you.
Thank you. You hearing me?
Yes.
Thank you very much, Mr. Chair. My name is Mike Pip. I am from the RC, the National University of Lesotho. I really appreciate the way how you organized this study tool, and we learned a lot. Thank you very much. Now my question, 3 of the presenters, maybe, the waste what we have and the collective waste we have, for example, in the community, the sewage system, we have that waste, and also the agricultural debris we have. So the combination of this, I didn't see any one of the presenters using the sewage system for this kind of purpose for environmental protection and also production of biogas. So what do you advise? We have a great ambition that to use this technology in Lesotho, so that if we propose, are you going to help us so that we can really do together this project using the slurry and many other agricultural debris in Lesotho? Thank you very much.
Thanks. I'm not sure if I got the question right. Sinja, do you know what is wind with debris? Or
yeah,
Johannes? Johannes, maybe?
So I believe
is it the household sewage? Is it this?
Yeah, I think he's referring to waste sewage, like the city sewer.
Yes. So maybe a short explanation. The city sewage, or from the household, the sewage is usually collected and treated in a sewage treatment plant. This is a different plant, which is very liquid, that the whole wastewater from households and industry goes in there in Europe, and then it's treated, and the effluent is goes back into the rivers, and the solid one is digested. If you have a question to this, we have also partners, at least one partner in our coming matchmaking tool, and we could raise the question there. And he is a planning company also for sewage treatment plants, and maybe there could be additional biogas plant then. Why we in Europe have different streams for these waste streams, like household and industrial sewage to organic waste streams, is because if we would throw all this organic waste also in the toilet, etc., in the mazzaretta, and then into the sewage system, then we would have a high polluted sewage, which causes rats and other pets in there, which we don't want to have in our close by neighborhood. That's the way we work in in Europe. US has a different system, we know that, and they treat it then in the sewage treatment plant. But then usually you have a higher costs in the sewage system, have problems with rats, etc. And additionally, you don't have those high valuable fertilizer at the end, and not as much as energy you could produce from a different separate or from a separate collection that it is. But within the matchmaking tool, which is launched soon, you will have the opportunity to find the companies which also planning companies for sewage treatment plants. Hopefully this answered your question. And sure, we can help on this. We have very developed companies dealing with sewage treatment.
Yes, Shisai, I've also forwarded you the email privately. If you have further communication, Shisai, please write to us, and then we will direct you.
Thank you very much.
So,
thank you.
Thank you. If there are not further questions, no. Maybe we can come back to the one remaining questions, and maybe Sinja, you could show the screen from all speakers, so we have all your nice faces on the screen again. And coming back to the one questions on the tipping fee, maybe this is possible to be answered. Mainly Bernadette and Reinhard, as Joseph doesn't deal with typical organic waste streams where you get a tipping fee or revenue. Bernadette, do you want to start?
I can, yeah. Okay. So the question was of the quantity or the revenue for the waste, right?
Yes.
Yeah. Okay. Yeah, as mentioned, it mainly depends on the effort we have to do with the material, and also in the video I think I mentioned it. So if it's just vegetable waste, which is easy to handle, the price is low. The more complicated it gets, the higher the price is. So if for all the animal or potentially animal waste, we need to do the thermal treatment, we need heat, we have to buy the heat since we don't produce it ourselves. So it's getting more expensive. The most expensive one is, of course, material which has to be pre-treated mechanically and also thermally treated with a high amount of waste, which we have to bring to an incineration plant. So the most complicated materials we have for like approximately maximum of 70 euros per ton.
Okay, thank you. Reinhard, you have a view?
Yeah, if you look at SSO, source separated bio waste, this really depends on the different municipalities, because the different municipalities have different fees for their collecting system. And here it's just an estimation. It's just an estimation because I'm not a recycling company or a collecting company, so I can just tell you that it's an average between 80 and 130 euros per ton.
This really depends on the city, on the region, and also on the country.
Yeah.
In Europe, we have a waste framework directive, which obliges to source separate the organic waste, which came into force only the last few years. And then the market raises up, and then also depends on if you have in your country a revenue for the produced energy, like guarantees of origin, special fees, etc., or feed-in tariff, investment subsidy, etc., etc. This really depends on the whole situation you face in the country and with which stream you deal. We hopefully could answer also these last questions. I don't see any.
Yes, maybe there was one point regarding the liquid fertilizer.
Yes, please.
Maybe I can add something to this point as well. In Germany, I can really make a statement to our market. In Germany, it's quite hard to get rid of the liquid fertilizer, you know, or to get something for it, to get revenues for it. Because we have anyway a problem with liquid fertilizers in the agricultural. And so if you bring now additionally the liquids from the biogas plant, it's more and more. And so you get more and more nitrogen into the ground. And this is what what nobody wants. And there's always, meanwhile, a limitation factor. And so in some regions, where you have lots of fields, the farmers are happy still to get it, but then they get it for free. In northern Germany, where you have lots of cows and cow farms, and where you have anyway too much liquid fertilizer and manure, there you have to pay to bring it out to the agriculture. So this is just to answer your question. Maybe it's a little bit different in Africa or in other continents, in other countries, but in Germany, where we have currently 9,000 biogas plants, you see this is a massive figure, and this is additionally to the normal cow slurry and so on. Yeah.
Yes, thanks. In Europe, we have a nitrate directive or regulation even. Now it's a directive, sorry, which regulates the nitrogen which can be brought onto the fields. And also we have water regulations, etc., etc. And we have in future also a phosphorus regulation. So for regions where the density of husbandry is very high, we have usually, or some regions in Europe, these are 2 or 3 main regions, we have problems with nitrogen concentration and phosphorus concentration in the groundwater. And here you would have problems to get rid of the digestate if it's a surplus nitrogen or surplus phosphorus, while in other regions where the population is lower, and especially the husbandry density is low, you usually have no problem if the plant is well integrated also in the agricultural sector. This always depends on the planning company, on the operating company which deals with it. So many plants are always at least a little bit linked to agriculture. Where it is not, the digestate is usually already upgraded, so the liquid phase can be get rid of within the sewage system. There are also plants already within this. Many plants in the some plants in the dairy industry. So, if there's no remaining questions and can't see anything, I would like to thank especially Bernadette, Reinhard, and Josef for your explanations, for answering the questions. Thank you very much. It was very nice to have you here in this auditorium. Thanks especially also to all from the auditorium, for all of you, even if it's morning or late evening. Thanks to all. Thanks for joining. If there are further questions or not answered quite well, please send us your questions. You find the contact details on our website, DiBiCoo.org, or here, Sinja also wrote it down in the chat function. So, thanks to all. Having further questions, please raise them. Also, we would forward it to the speakers and to the plant operators. Please use the website, check the website on ongoing things we have, what we do, and use also the upcoming matchmaking tool, finding companies which can help you find your solutions for the things you want to create. Thank you all. Have a nice day. And thanks especially to the, where's my hand? Yeah, yeah. Thanks to the speakers, especially Sinja, Florian, etc., who worked in the background to make it happen. Thanks. Have a nice day.
Thank
Bye.
you, Franz.
Bye. Thank you.
Thanks to you.
Bye.